Good morning, children. Today, linear equations in two variables, part 4. We'll be learning about equations of lines parallel to the x-axis and y-axis. First, let us see what is the equation of x-axis and y-axis. Consider the points negative 4, 0, 0, 0, 3, 0, 9, 0, etc. If we plot these points on a graph paper, we find that they lie on the x-axis. In fact, any point of the form x, 0 where x is any real number lies on the x-axis. That is, y-coordinate of every point on the x-axis is equal to 0. Therefore, equation of x-axis is given by y equal to 0. Similarly, the equation of y-axis is x equal to 0. As we have seen, equation of x-axis is y equal to 0. Let us see how can we find equation of lines parallel to x-axis and y-axis. Consider the equation x minus 2 equal to 0. This is an equation in one variable. So, it has a unique solution. And we can say x is equal to 2 is the solution, which is a point on the number line. But if x minus 2 equal to 0 is treated as an equation in two variables x and y, it can be written as x plus 0y minus 2 equal to 0. If it is an equation in two variables, the equation will have infinitely many solutions. So, the solutions of the equation x minus 2 equal to 0 can be 2, 0, 2, 1, 2, 5, 2, negative 3 and so on. In general, we can say 2, a is the solution of the linear equation in two variables where a is any real number. We can say every point of the form 2, a is a solution of the equation. So, the graph of the equation is a straight line which will be parallel to the y-axis. Here, the equation is x minus 2 equal to 0, which shows that x equal to 2 is the solution. If we write the equation as a linear equation in two variables, it will be x plus 0y equal to 2, where y can be given any value, but the value of x remains the same. That is 2, 0, 2, 5, 2, negative 3 and so on. Plot these points on the graph paper. We can see a straight line which is parallel to the y-axis. In general, the graph of an equation of the form ax plus b equal to 0, or we can say x is equal to negative b by a, is a straight line parallel to the y-axis passing through the point negative b by a, 0. Therefore, equation of the line parallel to the y-axis is given by x equal to a. In the same way, we are going to find the equation of the line parallel to the x-axis. Consider the equation y minus 5 equal to 0. Again, this is also an equation in one variable and it has a unique solution. Here, the solution is y equal to 5, which is a point on the number line. If y minus 5 equal to 0 is taken as an equation in two variables, it can be expressed as 0x plus y minus 5 equal to 0, which will have infinitely many solutions. The solutions will be of the form b, 5, where b is any real number. We can say every point of the form b, 5 is a solution of the equation. Therefore, graph of the equation is a straight line which will be parallel to the x-axis. Plot the points on a graph paper. For the equation y minus 5 equal to 0, we can see it is written as 0x plus y minus 5 equal to 0. That means any value can be given for x and y remains the same. So the solutions can be taken as 1, 5, 6, 5, negative 2, 5 and so on. Plotting these points on the graph paper, we can see a straight line which is parallel to the x-axis. Therefore, equation of the line parallel to the x-axis is given by y is equal to b. Question number 1. Solve the equation 2x plus 1 is equal to x plus 3 and represent the solution on the number line and on a Cartesian plane. For solving, bring all the x values to one side and the numbers to the other side. So it will be 2x minus x is equal to 3 minus 1, where x is equal to 2. Here it is an equation in one variable and x equal to 2 is a solution on the number line. We can draw an x-axis and plot the value x is equal to 2, which represents the equation on a number line. To represent the equation on a Cartesian plane, the equation x equal to 2 should be converted into an equation in two variables, which can be written as x plus 0y equal to 2, where it will have infinitely many solutions and the solutions can be 2, 0, 2, 3, 2, 5 and so on. We can plot the solutions 2, 0, 2, 3, 2, 5 on a graph paper and we can see it will be parallel to the y-axis at the point x equal to 2. Exercise 4.4, page number 77. Give the geometric representation of y is equal to 3 as an equation in one variable and in two variables. Here it is same as representing it on a number line and on a Cartesian plane. The given equation y is equal to 3 represents a point on the y-axis and it is represented on the number line by drawing a y-axis and plotting the point. To make it two variable, we change our equation as 0x plus y equal to 3. As x value is 0, we can give any values for x, but the value of y remains the same. Therefore, the solutions are 1, 3, 5, 3, 7, 3 and so on. Plotting the points 0, 3, 1, 3 and so on, we get a straight line which is parallel to the x-axis and we can say it is represented geometrically in two variables. Question number 2. Give geometric representation of 2x plus 9 equal to 0 as an equation in one variable and in two variables. 2x plus 9 equal to 0. From this we can say 2x is equal to negative 9 and x is equal to negative 9 by 2, which is negative 4.5, which is a point on the number line and on the x-axis. Draw the x-axis, plot the points and we can plot negative 4.5 on the number line, which is the geometric representation of 2x plus 9 equal to 0 as an equation in one variable. To represent 2x plus 9 equal to 0 in two variable, it can be written as 2x plus 0y plus 9 equal to 0. And we can give any value for y and x value remains the same, which will be negative 4.5. As it is an equation in x variable, the graph will be parallel to the y-axis and we can plot the points negative 4.5, 0, negative 4.5, 2 and so on, and we get the graph which is the geometric representation of the equation in two variable. With this, we finished our lesson linear equation in two variables, where we have learned what is a linear equation in two variable, how many solutions are there, how to find out the solutions for, and how to plot the graph in one variable as well as in two variable. Thank you.